Hello, I'm Daniel Bryant, co-host of the InfoQ podcast, news manager here at InfoQ, and product architect at DataWire. And I recently had the pleasure of sitting down with Michelle Krejci, service engineering lead at Pantheon. Pantheon is a web ops platform that runs the open source Drupal and WordPress websites and provides web hosting and management packaged as a software as a service offering to customers. The platform provides customers with a portal containing web-based development tools for designing and building their websites, and also provides access to a series of dashboards that can be used to understand and observe the resulting website and its performance. Although Pantheon provides hosting for the PHP-based Drupal and WordPress applications, the backend system powering the platform was initially written as a Python monolith, and the front end was created using JavaScript and the Backbone framework. Michelle joined the company 4 years ago, just as the business had secured more funding and had began scaling. The desire to release increasingly more functionality to customers, combined with the challenges of a rapidly growing engineering team, led from a move away from a single code base towards new functionality being built as a solar system of microservices. Michelle is a well-known conference speaker in the space of technical leadership and continuous integration, and so I was keen to explore some of the people challenges as much as I was keen to understand the technical challenges in relation to the Pantheon migration towards microservices and related technologies like Kubernetes and GraphQL. So welcome to the InfoQ podcast, Michelle.
Oh, thank you, Daniel. Thanks for having me.
In order to set the scene, could you briefly introduce yourself and your work at Pantheon as well?
I'm a software engineer at Pantheon, and I'm the tech lead for the service side of our infrastructure. So that essentially means all like the public-facing APIs and the services that serve it, which I'm happy to tell you is a lot more services than the one when I started here. So I've been here for about 4 years, initially as a QA lead, and then moving on to leading the services team.
Brilliant. And when we were chatting earlier, we said that the sort of Pantheon web app has moved from a monolith to like microservices. And we get into more of the journey later on. But what was the pain point that sort of made you move towards microservices?
Well, so when I came on, as I told you, I was responsible for being the QA lead. And I think what like the moment that Pantheon was in right now, so Pantheon, we are a web ops platform, and our customers are Drupal, WordPress users who need to be able to scale and deliver all over the world, stay up, elastic scaling, all of that. But because we run PHP runtime environments, it doesn't mean that our platform is written in PHP. We had this platform that was built really to prove out this concept. And when I came on, they were celebrating 5 years. A Series B funded company at this point had been able to prove out their ability to scale their container infrastructure. But they had done that at the cost of choosing technologies that allowed them to develop very quickly. And one of those choices was to put everything in a monolith. There's a lot of wins, especially when you're an early stage startup, to just having one repository, one platform. You don't have a complicated deployment pipeline. It's very clear, who's deploying, what's being deployed. Everything's there. There's no importing dependencies, no thinking about, how to organize your code. So a lot of wins from having been a monolith. But now we'd reached a point where we needed to really scale and prove out our platform. And that meant that we needed to scale our engineering team. And as we were scaling out our engineering team, we needed to be able to define discrete domains of responsibility and stabilize them. And I think their initial thinking in giving me the title QA lead, and they had never had any QA before. They had kind of come to me after seeing me do a number of talks about testing, integration, and deployment strategies, and found this title that was really an ask to stabilize where they were at, and to find some path forward for them to be able to assure some level of quality assurance for their customers. But really the problem that we had wasn't so much that things were breaking on the dashboard. It wasn't that. It was that feature development was at a gridlock. And feature development was at a gridlock because it wasn't clear what was a feature and what was a bug. What was it supposed to do? And that's really the question that QA gets at is, what is it supposed to do? What is the measure of success? And when you've been a fast-moving, innovative startup, you have all these great ideas. And now you have to sit back and ask yourself, wait, which of these things is how it's supposed to be? And which one of these things is an accident of dealing with some prior decision that was made?
Yeah, I think it's a very common pattern. So how did you get started with establishing quality within the system?
I looked at that, and there was one approach to that I think would have been a mistake that I'm proud that I didn't follow, which was I could have just blanketed everything that was with a test, with some big acceptance criteria test of let's cover the whole thing and let's force every pull request to go through this huge acceptance criteria test, and then we'll make a decision on a one-off basis about if that's actually breaking it or if it's the test that's breaking it. So that we could have done it that way. And that would have been kind of a Red Rover approach of like, bring your features over and see what breaks through. And I've seen that break a lot of people's innovation pipelines pretty quickly. And I didn't think it was the right thing for us. I felt, a lot of other engineers that I was working with felt really strongly that what we really needed to do was define the business domains and isolate business domains within a service where we could piece by piece pull something like, what our support offering is into a single service and have that well-defined and tested and understood, because the quality of something isn't just the inputs and outputs of a function. The quality of something is any person's ability within the company to be able to explain what it does. And if we haven't done that rigor of actually understanding the contract of that business domain, then having a test that says, that's green or red is not helpful. We talk a lot about technical debt, but conceptual debt is actually the greatest threat to a company. So it was really about tackling conceptual debt. And for us, microservices, I actually prefer to just call them services. I don't know about micro, but we just do have the regular services. And pulling out domains into services allowed us the opportunity to have this level of communication with the business. Are you familiar with Conway's Law?
Oh, for sure. Yeah. It comes up a lot in microservice talks, doesn't it? I'm guessing you were very much in the Conway's Law space.
Yes, Conway's Law. So for those who need a refresher, Conway's Law, or my interpretation of Conway's Law, is those who build systems are doomed or destined to build systems that reflect the communication style of the people building them. So if it doesn't make sense to the company, if it's not making sense to the people building it, it's not going to make sense. If there's wishy-washiness and a hand-waviness around what this thing does and like a lack of specificity, then that will show up in the design of the system itself. And boundaries are unclear if boundaries are unclear within the communication framework of the organizations that built them.
Yeah, it totally makes sense, Michelle. One thing I found really interesting you mentioned there, and I haven't heard of before, is this being QA driven. I find that really interesting because I think a lot of projects I've read about, I've been part of, or we've covered on InfoQ, we often see the dev team dive in and then QA are kind of late to the party sometimes, or not even invited, dare I say it sometimes, yeah. So I find it really interesting that you were driving it from a QA perspective.
Well, I had a unique opportunity as a new employee. I was given this title, but I had a Cassandra role in coming in and being able to say, I know you want me to wave my magic wand and have this all make sense and be testable, but really the real work of it is we're going to all have to eat our vegetables here, every single part of the business. And they were really receptive to that. I actually had talked to Pantheon a lot about that before I started. I even met with the CEO. I sat down with Zach to talk to him about this. And I said, listen, I don't want to be the end of the conveyor belt with QA. Like, if you're going to put me at the end to just say something, to deliver the bad news that this is rotten,
yeah.
I don't want to take this job. I want to be at the front of the conveyor belt. So I wasn't interested in taking on a position where I was just like doing some sort of self-flagellation for the company of like, well, we really could have done better, and then probably have my decision overruled anyway. Like, well, slap on the wrist, but we're going to get it to production anyway, I really wanted to make sure that they were serious, and they were very serious about figuring out what was going on. And what was going on was at the top of the conveyor belt, not at the bottom of the conveyor belt. And really kudos. It was really even at the top, at the founder level of wanting to make sure that we had everything in place. Like, we were changing the factory floor, as it were, at that stage. And that was a decision that they made, following a Series B funding, that like we need to really make sure that the factory floor is reset in a way that's going to sustain us.
Yeah, so before we dive into some of the technical stuff, so I'd love to get your input on that. I always find the organizational stuff is probably harder than the actual technical stuff. And obviously being new to the company, how did you sort of build those relationships? How did you get buy-in? Because you need buy-in from literally, like you mentioned, the conveyor belt. You need buy-in from almost everyone, don't you? From CEO you've mentioned, down through to people on the front lines, like the QA and the developers. How did you work to build those relationships and get kind of the buy-in for the migration?
Well, I had built a reputation for myself already. I had a presence discussing development pipelines. I was continuous integration before it was cool. Like I've been using all the buzzwords. I even made a Twitter bot that was like, continuous pumpkin spice, just like announcing different continuous things that were happening. And so I already had this sort of brand for myself as like, these are the things I'm going to care about. And so when I'm out there in the job market, that's already very clear that these are my values as an engineer. And I also made it clear when Pantheon approached me to take this role, I wrote my own description with them to like ensure, like I said, that I would have influence at the level that I felt like I needed to have it to be successful. That they were serious about this. I didn't want to take a job that was really just checking off a box to say that they had this thing. I wanted to know that they really wanted it done. What is harder though, and I think what you're getting at, because I've had these jobs too, when you're in the thing, you're not in negotiations, you're in the status quo and you see that you need to change course. That I think is a harder thing to do. The status quo is so easy and changing course is painful. And so it really requires a level of emotional, psychological labor. What I'm learning and trying to get better at is putting things in business terms and in dollars and being able to tell the story of, look at this exit that we all want to have, or look at this goal we all want to reach. And here's our trajectory. And here are the costs that we are incurring. And I've even done that before where I've been able to use some tools to measure time spent in toil and put a dollar amount around toil. And if we consider technical debt like a real financial debt, our CFO, has some books about what all of our debts are and, knows where everything is. If we consider technical debt a real thing on the books, we have taken out, we can receive financing, 50 million venture capital money. We took 100 million in technical debt, to be able to get us to the next launch. Then that's a real thing on the books. And if it was thought of as that, an actual cost in the books, then it's real in a way that doesn't require the emotional labor of engineers. To an engineer, it's just common sense. It's so hard to ask for a thing that just seems like it's our survival. But it's not visible to the business in those terms. And so finding a way to make that visible, it is actually debt. I mean, we say technical debt, but it's real debt and it's debt in money. And quantifying that and telling that story, keeping that ledger is the only way that I've actually succeeded in changing a company while I'm there.
Yeah, it makes total sense. Have you got any tips on how to visualize that debt? That's something I think I've struggled with. Something I know as a person called Adam Tornhill's talked about this at InfoQ and a few other places. And, visualizing it, I think makes it more real for even non-software folks. I wonder if you've got any tips on how you kind of translate that dollar value almost, or a value you can't quite communicate in dollars sometimes, but it's still technical debt. Yeah. How do you communicate that to the business?
Yeah, I made this recently, actually. So I have a line graph of debt incursion. And then I made these boxes of all of our projects and the technical debt that they each take on. And the description of why is this technical debt? Right? What did we not do that is going to mean debt later on? And I tried to tie that into both the engineering labor and the opportunity loss. And so I stacked these boxes up. Here are all the projects we've done the last year, and they each represent this dollar amount of debt. So Ward Cunningham's conception of technical debt was that it's necessary, but that it needs to be tracked.
Yes.
And so every project has a certain amount. And trying to stack that up and look at where we're at right now with technical debt, what that means in terms of, engineer labor. I mean, how many engineers do you know that spend most of their time laboring with technical debt?
Yeah, all too common, unfortunately.
Right. So I use that to describe the more of that we have, the less innovation you're getting because you're servicing that technical debt with labor. And that's how the interest accrues,
Yeah, totally. So has the move to microservices helped that? Because now you obviously got more things, more opportunity for debt. No.
God, no. No one should no one should think that microservices is going to be the end of technical debt. It has been able to identify it better. Can I say a little bit about what the path of moving to microservices was for us? And then you can kind of see where that creates its own technical debt and alleviates other kinds of technical debt. So we have this monolith that is bleeding edge technology at its time. It's a particular flavor of Python, a twisted Python, which is an asynchronous kind of Python, yeah. And, had a very, let's say, a creative implementation of it as well.
Nice.
And it had a very early version of Cassandra. We obviously need a highly available distributed system. We're storing the configuration of hundreds of thousands of sites. So our CAP theorem equation just dialed to needing something like Cassandra and a Cassandra cluster. And then it was all being served on the presentation layer is Backbone. And nowhere in our stack did we need to define what models look like or data. We kind of rolled our own ORM 3 years into the project. We were just essentially throwing around dictionaries. So the conceptual debt here is in not even knowing what these concepts are to hold on to.
Almost untyped entities, in effect.
Exactly, yes. And you can imagine how fast you can go when you don't have to make a schema change. Boy, you can go really fast. That was, I think, the right choice. But it has a cost. And we were ready to pay that cost. So the first thing that I did, the first service that we pulled out was the support service. So all the code that served our ticketing system where customers are able to contact customer success and they're seeing the replies, and that all works with a number of third-party services. And so we pulled that out into a container just as Kubernetes came out. Ah. And so it was our first Kubernetes give it a go, because all the cool kids were playing with that.
Yeah, no doubt.
Don't want to be left behind. Gosh, that was about 3.5 years ago now. And some mistakes we made is that I was so ambitious. To me, this was my golden child, right? It was our first service. And I just polished that service. Yeah, it was the most unnecessary levels of testing and validation. I was the QA engineer, goddammit. It was going to be so tested. And it was an unnecessary level. It just, so many hopes and dreams. I was so interested in event-driven development. I had these ideas of changing everything. I was going to fix everything with this one system. It was going to be the model, the Adonis. And now it's a piece of technical debt that I'm actually working on removing this week. But at the time, it was just I spent so much time just wanting it to just be the exemplar of what a service should be. And it had all the ideas in it. Only 20% of which were actually implemented. And in the end, I still had to route it through our monolith, because our monolith was serving three important strategies. First of all, it was the thing that could route, because it was our API still for the clients. And it was our aggregation layer and our authorization layer. So it's the layer that can aggregate, to the front end, and it's authorizing. So even though we pulled this service out, the monolith still had a route to it. So, monolith is now, among other things, now additionally a gateway. Yeah. So we just added more weight to the thing that we're trying to chisel away at. But the next thing we did, because we're now in love with Kubernetes, was I moved on to the front end, and we put all of our front end assets into a Kubernetes deployment and service. And that was honestly transformative for us, because the process to deploy the front end was just cumbersome. And crucially, rolling back was cumbersome. It could take us up to 45 minutes to roll back a bad deploy because of the way the deployment was structured. And then with Kubernetes, we could roll back a deployment within 20 seconds. I had come from the world of Chef and Ansible and Puppet, these provisioning tools that when you had to turn A into B, you just, took A and transformed it slowly into B. Whereas the world of containers is, well, if you have A, then you just make B, and then you delete A and point to B. And then, in a world where I can roll back, I can just go back and forth if I need it. And that just completely transformed everything. The front end was able to speed up their work quite a bit. And they had the confidence of knowing that if things were bad, it's bad for 20 seconds. You can just roll it back and no one can see. We really were able to reduce a lot of errors that were very painful. And then we could start to have a testing cluster, able to properly test it, just the front end in isolation from everything else. Because we could just point the front end at a staging version of our monolith, and they were working independently at a much faster pace. So we were able to at least move them into a faster development cycle.
That's super interesting. Out of curiosity, was the monolith running on Kubernetes too? Or did you completely leave that where it was?
Yeah, actually, we still haven't moved that to Kubernetes because of Cassandra and our Cassandra clusters and a number of other complications. It would be very complicated. It's not impossible. It's just not like high priority right now. But I think that'll happen within the next 6 months. Our monolith will be in a cluster. So then we can maybe have the advantage of running that nice undo.
Yeah, nice.
roll back, which is just like such a great psychological safety net, honestly. And even if you don't need to use it, having that as an engineer is a game changer. To know that like you just have a command to quickly restore things back to where they were.
Yeah, very interesting. So what I also heard is sort of by decoupling sort of some of the back-end API stuff from the front end, you can literally sort of the developer experience on the front end got so much better because I'm assuming people could iterate faster. They weren't kind of coupled to the deployment of the monolith, that kind of stuff.
Exactly. And they didn't even have to concern themselves with the like to them, it's a black box now. It's just like consuming any other kind of API. There's no need for them to even think about creating an instance for themselves. But that got into our other challenge, right? So now, what does the development challenge look like? So we've now complicated the world because we have 2 services. You could kind of get on without having like a sandbox instance or, your development experience with support. But the dashboard experience is crucial to a lot of people. Like they want to sort of see what's happening there, especially when we're working on defining models and changing the API can have significant impact. So now we have all this missing tooling because we just complicated the whole development experience. We don't just have a monolith sandbox anymore. So then we took time to invest in a tool. It's very clever. We leveraged Kubernetes itself. Are you familiar enough with Kubernetes and some of the ways that it uses namespacing?
Yeah, but I suppose some of our listeners might not be, so feel free to add a bit of flourish around the sort of concepts if you'd like.
Okay, well, Kubernetes is just an orchestration tool in and of itself. It's not a place or it's not a platform itself. It's a tool. And one of the things that it gives you is the ability to label like things, shall we say. And leveraging the handles that Kubernetes gives us to specify a like space. What we did was we used the namespacing tool, so that particular handle, to provide a sandbox for every engineer. So every engineer would have a clone, essentially, of production. Just for the listeners, using this example of this support service, it's deployed to a production namespace. And that namespace is special because it tells us a lot about what kind of cluster it's going to run on, what kind of backend infrastructure it's going to run on. And it has particular configurations because it's special. It's the production namespace. But we can copy all of the configuration on all the pointers at all the containers. So that namespace knows all the containers that are meant to run in that namespace and how we know that they're alive and all that configuration. We can copy that into another namespace altogether. And that's essentially what we did, except we created basically a sandbox namespace that would be almost entirely a clone of production. And when an engineer is spinning up a sandbox environment, we copy that clone into their environment. And namespaces are a nice way of being able to contain an entire, ecosystem, a whole solar system is probably the better word, of services that we can test as though they're production. And the work to do that, is something that we can automate and turn into its own service. So we created a service, an internal tool that with a command will spin up this whole environment for me. So I just tell it to create, Krejci is my handle, the Krejci sandbox space, and it will copy everything roughly from production. Obviously, there are certain differences in a staging environment. And then I have an entire ecosystem to work on. And so being able to make that easy and intuitive to every engineer without needing necessarily to know the internals, these are replicatable tasks. Spending some time investing in that tooling early on was such a smart decision. All the engineers who had been working on Kubernetes realized that this was it. Like if we couldn't figure out how to make this easy to use, then Kubernetes was going to be just a cluster for us. So we put our pens down and invested a lot of time into getting tooling and replicatable tasks together. And without that, I don't know if we would have been successful letting, 1,000 blossoms bloom, as it were, with all the services that came after that.
The developer experience, I think, is super important. This is a very novel sort of take on it. One of the things that popped to my mind is how do you handle data? Can you copy data from production? Is there any PPI kind of issues there? Do you obfuscate it? Or how much data can you copy around, I guess, as well?
We don't copy any data from production. for some of the reasons that you listed, plus 1,000 more. So we don't do that. What we had been doing mostly is requiring engineers to manually go and click around and make their own world again. As though they just got a brand new, untouched Pantheon, and their client one, their customer one. That's not super great, but
yes, I was thinking of that. I guess you could automate some of that though, yeah?
Right. And, we have some shared instances now. There's many sandboxes that point to one staging monolith, as it were. So they don't have to replicate data. They just, they're changing the world around it. But the monolith just goes strong, It really kind of depends on where you are in the development stack. But right now, actually, so fast forward a couple of years, and now we're tackling that aggregation and authorization problem I talked about earlier with Apollo GraphQL Gateway. And we're moving to GraphQL, which is a great way to start getting models and schema defined and realizing the stream of really being able to get our hands around what we're actually talking about. And one of the great things that gateway provides us, in addition to this ability to completely start to strangle the monolith and go through another gateway and use that strangulation pattern. But the other thing it gives us is the ability to serve mocks. Because of schema first development and having just defined the schema, we can then mock it. And that means, first of all, that the front end and the back end can work independently. The back end to serve the contract of the schema and the front end to consume the contract of the schema. But it also allows us to have mock data in a staging environment so that, we're going to have some challenges there because now we're going to have the question of what are you testing?
How do you define the contracts as well? Do you have to, I guess you have to get together at some point and say, this is what I think the model is, this is what I think the model is, and then basically work together front end, back end, and define the schema somewhere?
Yeah, we love the schema first development, right? The where to put the schema is controversial, and I'm sure whatever we do, we're doing it wrong. I already changed it 3 times. We're like, well, it'll have its own repository, or no, it's going to live in the service itself, or no, it all needs to be in one place. But then, what are you looking at? Are you looking at the production schema? Or are you looking at development schema? How do you know what you're looking at? You can see, it trickles all the way down. I'm going to have to go back to Git flow. We want this to be simple and intuitive, and right now it feels complicated. Yeah, sitting down with front-end engineers, ideally we're with design and product as well, right? And we're identifying what all of these things are, finding some standardization around it. That's honestly the fun part. And really the point of doing microservices, which I will use that prefix, is that we are able to just get to that work because we can have some standardization now about what our services look like. The customer-facing services are Python 3, Django, SQL backend, just we have it templated with Kubernetes templates, with our continuous integration templates. It's all, we literally have a tool that will allow you to just quickly spin up a service with all of our best practices in it. And then you can just focus on the schema. Because that's, how to do it, those architecture questions should just be easy to replicate. But what you're building is the crucial thing.
I really like the idea there. So what would your typical development process and the pipeline look like? Say we've got a business idea come in and we're looking to deploy this into production and actually observe this. What's the kind of flow it would go through, the idea to code to deploy?
I appreciate that you've given me permission with a would.
Yeah.
Yes. So this is the ideal that we think that we've achieved. We as engineers want to sit down with product and design and, look at the request here, look at the ask. Let's say there's a new feature and we're looking at what this is going to require. We want to be able to identify what domains that feature touches on. Because it's never just one thing, it's always a little bit of an idea of what a site is and a little bit of how we configure environments. Okay. So it touches on all of these things in these ways. So we have a sense of how many components it's going to touch on, and the change will be in there. Let's say that the change requires a new service, an entirely new feature. Then we work together to design the schema that's going to serve that page. And we're able to mock it immediately. So it's not it doesn't have to be something that remains, like a JSON dictionary for us to try to visualize. It's something that we can immediately create and document and try to produce in a very light way with mocks on the front end and be able to set that correctly. And then we're able to see what's missing from the back end. And, ideally, the service that will be able to fulfill the remainder of that contract, would either be an extension of an existing service or the creation of an entirely new one, whose contract is very clearly defined in that schema. You need to produce this thing in these ways. And then it's really up to engineers, right, how to serve that contract. And we have some tooling in place to serve that contract, but there's that clear definition of done with that schema. And hopefully they'll be able to work independently of each other. That's the goal anyway from this customer-facing consumption of an API.
Yeah, very cool. So when engineers have done that backend API, is there a pipeline they then push this down? Like, so it gets unit tested, I guess, or unit tested when you're developing that anyway. But it gets, say, integration tested, maybe deployed to a QA environment, staging environment, and then through to production. Is that the kind of general approach?
It's funny because I was hired as a QA engineer, but I don't see that with where we're going. And the idea of a staging environment also doesn't seem right for us. So part of what GraphQL schema gives us, so just taking a couple steps back here, everything is backwards compatible. It has to be backwards compatible. There's no breaking API changes. It's additive. So the backend can start serving that without the front end consuming it. So it can be made available, and it's really up to the front end for when it's going to consume the data provided.
Oh, interesting. So you might have, say, like multiple versions of a service, even like sort of in production, but then only one actually released to the end users.
That's right. So we would have that opportunity in that sandbox environment that I described for you to say that this is what it looks like to consume it, and to have that very lightweight and actually on a pull request on the front end, it spins up a whole new sandbox environment for product to be able to test, what that change is going to do to the front end and take a look at that. And it's really the approval of that environment. Like, yep, that's all right. And it's not correct to say a staging environment because it's consuming the production gateway data. But now this is the instance of consuming that. And that's what that change looks like. And then again, we have that opportunity to roll back very quickly.
That's super interesting. Yeah. So, we're coming to the end of our time, Michelle. There's so much I think we could break down. We could do a couple of podcasts here, no doubt, in terms of just like focusing on front end, focusing on back end, focusing on, I think continuous delivery and business stuff as well. There's lots of great stuff here. What would be your one key thing you'd like to share with listeners? Say they're about to embark on this journey. They've got the similar pain points you've talked about. They want to move to microservices. Their management maybe is saying move to microservices. What would be the one thing you'd say is really important, or the one thing you've really, learned to focus on?
I think you need an easy win fast. And I would recommend identifying something that could be served with a fire and forget event queue. I think, when you're looking at something like a monolith, it handles so much, right? It is the authorization layer. Monolith it's so many things besides data serving. It's doing a lot. And so that's a lot to tackle. And so if there are areas, and for us, it was sending emails to clients after certain events happened, and some internal tracking tooling that we had. There are a couple of key areas that as soon as I switched to that strategy, and we didn't talk about it, I just started to identify every possible area where I could just fire an event and have another service consume it. That was the simplest way to get a win because it didn't require networking and setting up those kind of connections. I didn't have to think through. I just accepted that authorization is terminated at the monolith, but it gave us the ability to start playing with patterns and get some quick wins and clean out some of that gunk. So I created about 5 services within as many months, just when I switched to that strategy. And that really started to exercise those muscles. And there's so much to figure out here when you're starting to create solar systems of infrastructure. Don't complicate it. Find the lowest hanging fruit there, get quick wins, earn trust and confidence.
I like that a lot. Excellent. Thank you very much, Michelle. Thank you for joining us today.
Thank you so much for having me, Daniel. It's been fun talking about all this.
What is happening in the programming language world? Which language has gained wider adoption? Check the Programming Languages Trends Report to make informed mid- and long-term decisions or to choose wisely where you invest your time.